Section 3.5 in UMTYMP Algebra 1 is all about the special cases of factoring. There are 4 that we are going to learn about and that you should definitely memorize, and I will teach you a couple of tips and tricks along the way when using them. The first special case is called difference of squares. We actually saw this last week when we were multiplying out two binomials multiplied together, and they were the same terms but different signs. Difference of squares is when we would have two terms that are squared, so in this case a squared minus b squared, and it factors nicely to a plus b times a minus b. Let's look at a really quick example. Here's a great example where we can use difference of squares because we have x squared minus 9, both of which terms are squared. In fact, this is actually x squared minus 3 squared. And because it follows the pattern of a squared minus b squared, we can then use the difference of squares formula. That leads us to the factored form of x plus 3 times x minus 3. Let's move on to the second special case of factoring. It is a perfect square trinomial. We also saw these last week when we were doing the multiplication of binomials. Just a reminder, the perfect square trinomial is of the form a squared plus or minus 2ab plus b squared. When we go to factor it, it all depends on what sign was in front of our 2ab term to depend what sign we put here. Again, the sign here, plus or minus, should match what was here. It would factor to a plus or minus b quantity squared. Let's look at a quick example of this one. Here's a great example. 9x squared minus 42x plus 49. See if you can figure out what a and b would be in this particular expression. Unpause the video when you think you figured it out. Hopefully, you figured out that a is 3x and b is 7. Now we can go ahead and use the perfect square trinomial factoring rule in order to actually factor this. It should factor to 3x minus 7 in parentheses squared. Hopefully that's what you got. The next special case of factoring is called the sum of cubes. I bet you can predict what this would look like. That's right, we literally add together two cubes. So a cubed plus b cubed. This is going to factor to a very special formula. It factors to a plus b times a squared minus ab plus b squared. Might as well look at one quick example for this one as well. Here's our example, 27 plus 8a cubed. See if you can figure out what a and b would be, and then try to put it in the factored form. Pause the video and unpause when you have an answer. Hopefully, you saw that a was 3, b was 2a, so the factored form would be 3 plus 2a times 9 minus 6a plus 4a squared. Now, there is one last special case that we are going to need to memorize. That special case is called the difference of cubes. It is very similar to the sum of cubes, so let's go ahead and look at where it differs. This time, because we're dealing with the difference of cubes, we have to subtract the two cubes that we are dealing with. So a cubed minus b cubed. Notice the formula looks very similar. It's just a couple of the signs are changed. A minus b times a squared plus ab plus b squared. Now, the way that my students always remember the signs for when this is factored is the acronym SOAP. SOAP stands for same, opposite, always positive. It matches the signs for both the sum of cubes and difference of cubes formulas. Notice, the first sign is the same as our original relationship, so for the sum, it's the sum. The second sign is always the opposite, and then the third sign is always positive. This works for both the sum of cubes and difference of cubes. These two formulas, the sum of cubes and difference of cubes, are very important to memorize, so please be sure to do this. Technically, after watching the next video on section 3.6, you will have other fallback methods if you forget the difference of squares or perfect square trinomial factorization. But the sum of cubes and difference of cubes you have to know. I want you to go ahead and practice using these formulas. Here are two examples for you to try to factor on your own using the above special cases of factoring. 16x squared minus 25 and 27x cubed minus 64y cubed. Again, please pause the video and take the time to work these out on your own. Then, when you unpause the video, you can check your answers. Hopefully, these are the answers you got. A was a difference of squares. In fact, it was 4x squared minus 5 squared, making A 4x and B 5. Therefore, it factored to 4x plus 5 times 4x minus 5. B was a difference of cubes. A was 3x and B was 4y. Therefore, this factored to 3x minus 4y times 9x squared plus 12xy plus 16y squared. I have one more example for us to try and combine everything we've learned so far about factoring. I want you guys to go ahead and factor 6x cubed minus 24x. Now, keep in mind, in section 3.4, we learned other strategies as well for factoring besides just these special cases. I need you to double check what our first step for factoring should always be and try to do that first. Then you might be able to use a special case of factoring. If you need to, look back at your notes, try this problem, and then come back to this problem to see if your answer matches. Hopefully you remembered or looked back in your notes to see the very first thing you should always check with factoring is if there's a GCF that you can factor out. In this case, there is. Both terms, the 6x cubed and the 24x, can factor out a 6x. So if we take out the 6x, we are then left with x squared minus 4. And then we want to make sure we fully factor it, and this factor can still be factored further. In fact, x squared minus 4 is a perfect example where we can use the difference of squares. Let's go ahead and factor it. This now factors to 6x times x plus 2 times x minus 2 by the difference of squares. Nice job!